How can you reconnect to your game on a game server when you get disconnected? That's what we're going to talk about. So, in the naive implementation, we have our client application, which could be your computer or phone or device of any kind running a software which we would call the client app. The client application would be the game that you boot up on your computer. Then we have a game server. Now, this is a very simplified version of it, and this is actually how my game worked before the redesign that enabled the reconnection. So what you would do is you would connect to your game server, and the way you would know the address for that is because it's baked into the app. So when we program the app and send it to you, it contains the address for this game server, and you just open a connection to it. And then the game server can send you messages too, like, yeah, you have created a game and this is what's happening in that game. And you would be sending messages like, okay, I want to do this. And they're saying, okay, because you did that, this is what happened. And your client application would show that to you. And the kind of steps you would need to go through for this would be on the game server. First, you need to connect. Then you will make a game. And then you might have other players join. Okay, and then everyone is ready, and then we start the game. This part is kind of preparing the game for you to play. So once this is all done, we'll just put that off to the side. Now you're actually in the game. So in the game, you might say do game action, which could be attack, move, use item, things like this, maybe chat. And the game server will send updates, and these will be saying, okay, you attacked, you moved, or you used item, and it sends that to all the players so they can see that you did that as well. And if you want to say use item that I don't have, then the server would be like, you can't do that, or something like that. So that's kind of the basics for a game server and how you can't do something you're not allowed to do and how everyone could be broadcasted that information. Now we kind of start to realize these are two separate basic categories of what the server is doing. First, it's getting you ready to play. Then you're actually playing the game. And this part is perhaps a lot less intensive on the resources of the computer than this would be, because especially if it's a real-time game, the computer, the CPU, the central processing unit, and all the RAM and everything is mostly going to be dedicated to this. And this is the part that you might want to split into multiple computers to say like, okay, we have like 10 games already on this computer. Let's go rent another computer from the cloud service to run the next 10 games. And that would be one of the benefits that you would get from splitting your lobby, which I would call this the lobby responsibilities, from the game server. Because now you can have multiple game servers and a single lobby. If you do this, there's going to be complications because now there's actually multiple addresses and we have to somehow tell this client to go to this game server. And the client is not going to necessarily know where that is because this might be something that didn't exist when the client first connected to the lobby. So let's start another little diagram down here. We'll bring our current situation. So instead of having this, we are now going to have multiple game servers and one lobby server. So the client app will say, hey, I want to make a game. You'll organize your game. The lobby server is going to send you connection instructions, and that is going to include the address for the game server you need to go to. So if you're on game server 1, your game is, that is. then you're going to know that because the lobby told you in the connection instructions you have to go to game server 1. And you'll say, "Hi, I'm here for my game." And the game server is going to be like, "Who are you?" Because you really can't have it that anyone's allowed to do this. If random bots on the internet are just going to your game servers and joining random games that they were never intended to be in, that would be a huge problem. So not only do you need connection instructions, you need some proof of your identity and your right to be in this game on this game server. So another thing we're going to give to you is your session claim token. Now these names are just my own names for this. That's not a standardized thing that I know of. These are just words that sounded like they described the concept when I was coming up with all this. So what a session claim token is basically it says you're allowed to be in a game name or game name, and you could call it like my cool game, right? Whatever you named it or got assigned as a name. And the server one, or I guess it's game server one, we're calling it. Then you also need to know who you are, so like the user, because games have multiple users. And if you show up and say, "Hi, I'm here for game one," and I want to control all the characters in that game, but some of them are for player two, that shouldn't be allowed either. So you'd say, "This is your user ID," which would be like, some number or whatever it is, a unique thing. Okay, so you would be like, "All right, here you go, game server. This is who I am and what I'm supposed to be allowed to do." And the game server would be like, "Okay, but how do I know you didn't make that up? Because you could send anything you want to this game server." So we actually can't just have it be just this plain text thing. So instead, when the lobby server sends this to you, we need to know that you didn't modify it and that it came from an authoritative source that we trust. We trust the lobby server because we run it. We run that on a remote thing. So instead of giving you a plain text thing, we're gonna send you. Let's put this over there. We'll just remember the idea of that. A session claim token, which is going to be like this, like something that you can't read. But the way we created this was with a secret. So it's a cryptographic secret, which we could call our like session secret key. When the lobby creates that, they apply some formula that includes a secret thing, which would also kind of look like this, some unintelligible string of long stuff that you could never guess because it's so long and so random. And they apply that to this string, and it gets turned into this. Now, when this gets sent to the game server is like, "Oh, you have a token." And yeah, that looks like it's the right number of letters that we would expect it to be. Let me apply the secret that this game server also knows. They would both have the same secret shared between them. And then they would unwrap that and they would say, "Oh, I see that you're here for my cool game. I see that you want game server one, and I am game server one, and I see that your user is whatever." And they know that this is a verifiable thing because they were able to decode your cryptographic string into this. And there's no way, unless you had the secret, could you have modified this or created one. Now they know that this is all verified information, but what else could be the problem is, well, is this game even on this server? So we need another concept, and that is when the game is created on the lobby server, how does it get handed off to the game server? So when you connect to the lobby server and you set up your game and you say everyone's ready, at almost right before you got your connection instructions, or actually yes, right before you got them, we needed to tell the game server that people are going to be coming over to you, and you're going to need to know that there's about to be a game on this server. We can do that in different ways. One way would be to say, hey, game server, there's a game coming, and you need to get ready to host that. But the problem with that is that would necessitate that the lobby knows the address of every game server, and we could probably facilitate that with some mechanism, but it's kind of annoying because game servers get created and destroyed all the time if you're scaling them and down, like scaling up, scaling down. And then you'd have to report them to the game server, and I didn't want to go that way. So what instead I did was I used a centralized store. We call it a store, it just holds data. It's in this case, it's a Redis database, but it's actually not Redis, it's Valkey. But if you know what Redis is, this is almost the same thing, except it's open source for real, and that's just an implementation detail. But in any case, it is a place where you can store data. And any of our servers knows where to find this. This is always running somewhere cloud, in our cloud service. And the lobby would say, all right, there is a pending game setup that is supposed to be on game server one. And this would get written there right before your connection instructions get sent to you. So we'd wait till we knew that this was done so that when you actually try to connect, the game server is going to be able to find it. So the first person for that game joins, and the game server realizes that there's somebody asking them for this trusted information that they believe is valid and real. So their next thought is going to think, is there a game already running on me on this server? Well, there's not because this is the first person to join. So their next thought is, let me go see. Let me ask, is there a pending game setup? And they're going to find that yes, there is a pending game setup for this game. So after that request to the store is done by the game server is going to say, oh, all right, let's run a game. And this is going to now be inside the game server's memory. And it can attach the player and say, yeah, you joined my cool game. And that is all good because we found that there actually was a game to give you. Now, when another client joins and they say, hi, I'm also here for my cool game, they're just going to say, oh, we have that. Yeah, we have that running in the game server. So that is totally fine. And here you are with all the information for that game for you to need to play. Now we have players in a game, and we can finally start to think about how we can reconnect these people now. So let's get our second player back and give them their arrows. So this is their open connection to the game server. But now we want to have somebody disconnect. And this is also, these are no longer open connections in the current state that we have, because you disconnect from the lobby once you've reconnected to, or once you've connected to the game server. Okay, so we have two players in a game on game server one, and we want to have someone disconnect and then be able to reconnect. Let's have this person disconnect here. So this person is going to disconnect. Their little connection arrows are now gone. And game server one knows that because they're monitoring all connections the whole time. They can see when a connection has closed. And they know that this person didn't leave on purpose because this person didn't send the I want to leave game packet. They just stopped sending, or they stopped their connection abruptly. So this game server knows, okay, this person disconnected by accident and they might want to come back. So for that to happen, we need to have some way of identifying this client when they come back, if it is the same player. And we need to know what time they disconnected so we don't wait for them indefinitely. So this game server, in addition to holding its games, is going to also hold a list of people who might reconnect. And I call that reconnection opportunities. So this would be player 1244 is I think who we called them down here. Yeah. And we also know that was at like 12 p.m. or whatever time it was, because eventually anyone who's still left, player one, is going to say, well, this person, like, they lost power at their house or something. They're not going to be able to play, but I'll just keep playing this game without them then. So we would say every 10 seconds or so, there's going to be a heartbeat loop in the game server. And then in that loop, we will say, is any reconnection opportunity expired? And if it is, we will delete it. So we're basically constantly checking, not constantly, but regularly checking if this person's reconnection has timed out. But let's say it hasn't timed out yet. That means this person is now, they're going to turn their computer back on after it crashed, and the only place they know to go is the lobby server. And they need to get new connection instructions to get back to this exact game server that they were on. But how are they going to know that? That that's the one to send them back to. How does the lobby know to send them back there? Because right now, the only reconnection opportunity that has any knowledge of this is the game server, but the lobby needs to know about this as well. And you might already guess the solution is we're going to write to the same shared store. So we're going to, at the same time as we record their reconnection opportunity, we're going to say player disconnected at 12 p.m. on game server 1, player 1244, because it's that specific player. And now this client app is going to connect to the lobby server, and they're going to say, hey, I'm here, and this is who I am. And when they connect, they're going to say, I user 1244. But once again, this is a problem where the client, we can't just believe them to be user 1244, because then any random person who says that could eventually find themselves getting sent back and taking over this user's characters. So we once again need a trusted way for this client to say who they are so that we can believe that we should send them back to that server and we don't send like a malicious user there. There's two ways that I'm currently doing this, and one is sort of simpler and one is more complicated, but they're both not too bad once you've already thought of it. So first of all, if this is an authenticated user, meaning they logged in to our service, our identity provider service, which is a separate thing, but like when you log into a website, you get credentials in your browser that your browser cannot manipulate or change. Similar, well, it depends how they do it, but for us, you get a user ID cookie because you logged in and we set this cookie on your browser. The browser itself can't really, or like the code running within the browser is they call sandboxed. It's like you're playing in a sandbox and you can't go outside that. So this cookie is not manipulatable by the code, changeable. It is only something the browser itself can set. And when you connect to our authentication service or our identity service, we say like, hey, you should set this and say this is who you are. So we will either send your user ID cookie to the lobby, and then it knows who you are. It's going to independently verify that to our, let's get another little box here, to our auth service or the identity provider service. It's going to say somebody with this auth cookie connected. Does that, do you have a login user? Like, is there somebody who's actually logged in with that ID? And they would be like, yeah or no. And if not, they would deny you. They would just connect you to the lobby regularly, and you'd have to make your own game because that means your token expired. And even though the cookie is maybe valid, then it just you timed out on your logged in. You have to log in again. Then you could go back to your game still, but I feel like this is a bit of a sidetrack to this, but I guess it is important. This is how we would know who you are, one of the ways. And we don't have to get as actually into the nitty-gritty details, like how do we know that the user didn't make up their auth cookie? Because you can manipulate it maliciously, but we'll just have to believe in that for now, since it is kind of separate. But we'll say we can trust you as a logged in user, and that's one way we would know who you are. And then we would check the store. Okay, this is a logged in user. Is there anybody by this ID who is currently disconnected? And yes, there is. So then we would say, hey, go to go to this game server and we will give you another session claim token. Okay, so yeah, we will give you a new session claim token. They can only be used once per attempt to connect. And this one would say, okay, I got this session claim token. I'm supposed to connect to this game. And it works exactly the same way it did the first time, except this time the game is already started. So the only way that we're going to let you in is if your reconnection opportunity is still live. And if it is, then we give you a full game update, and you're basically back in the game at that point. So that is the reconnection opportunity getting deleted at that point because you've claimed it. You've said I'm back, and then we say okay, great, and then we will at that point on the game server we will unpause the game for the other players because in my game it doesn't make sense to like you can't skip people's turns and stuff. If your game is more of a I don't know, first person shooter or whatever, there would be no need for this. But any state you want to manipulate, if you think of old like StarCraft and Warcraft 3, they pause it, and then when the person comes back, it gets unpaused. So this is the point where we would unpause it. And that's how it works generally. The other kind of side details is what if you're not a logged in user? Well, the simple answer is you're not allowed to reconnect to games in that case. But it's nice to let guest users reconnect because if you make a good impression on your guest user, they might sign up for the game. And it's not too much of a stretch to do this. So the way we do that is with another token. This time, when you connect, you are a guest. And instead of a user ID cookie, you have a reconnection token. And this token is just written down in local storage. Local storage is a way the browser can store data, but you can go change that whenever you want. Like if I go in here and I go to storage and I go to this website, like excalidraw.com, there's cookies, which the code can't change itself, but there is local storage, and they've set some things for me. Apparently, the theme is stored here, which I've never gone on for this website, but you can just make a new one and be like, reconnection token and set any value you want. And that means the user can just make up their own reconnection token. But we're going to solve that the same way we did before, which is we're going to create a token with a cryptographic secret. And the first time you connect, before you ever disconnect, we will give you that reconnection token. You'll save it in your local storage. And now when you reconnect, you're going to say, I'm guest 1244. I guess we could say they have the same number, but they're a guest this time. And the lobby server will be like, okay, is there any guests with a disconnection opportunity of this ID or this name because your name is created randomly as a guest every time you connect. So we could still handle it the same way. We could be like, okay, this is a guest. Yes, they've disconnected. Then they would say, all right, you have, oh, important detail. Because this is the second connection for this guest, the lobby server is going to try to just assign you a new random name. But if they do that, you wouldn't be able to match up with your original 1244 that you were given the first time you disconnected. And that's when you connect to the lobby server, you say, hi, I have this reconnection token that you gave me. The lobby server will say, oh yeah, that matches the secret. It was a token created with our secret. And they would also know if it was ever used before, because we will always check if one was claimed and say it's no longer usable. Then if that is all true, you can reconnect the same way. You will get a session claim token, which works the same way from there on out. But you can see the guest is a little more finicky because it has no way, originally it would have no way to know if you were the same guest as before, because guests kind of by definition are per connection, unless you have this token we gave you the first time you connected. So that's a guest reconnection. Okay, finally is session preemption. So now that we have all of this infrastructure, we can now have a situation where somebody connects from a different computer. This is now an auth user only, because unless you transferred your token manually and copied it to another computer, and then like as a guest, your guest token, then you could do this, I guess. Go to another computer as a guest, but it'd be very manual intensive, and like why would you do that? Mostly this is to facilitate authenticated users who have joined a game on one computer and then they went to a different location and they don't have access to that device and they want to go back into that same game. So it's almost the same as reconnecting, except it's like you're reconnecting from a different device, which disconnects the other device and then puts you in place of it. So in this case, there is no reconnection opportunity yet. Instead, it's more what we really have besides this is a kind of an evolution of that plan. So now, instead of reconnection opportunities in the store, we have player game sessions. And these player game sessions have current game, which could be null or string, like it could be the name of the game, or nothing if they're not in a game. And this is also going to hold, are they disconnected? Disconnected at time. So that's only if they were disconnected. And this is going to function exactly the same way as when they disconnected before, except now we also know if they're in a game already and not disconnected, because then you join the game. There is no reconnection opportunity for you on the game server because you are in the game on that other computer. And just like before, you will prove who you are. You will say, hi, I'm authenticated user, whatever. They will say, is there a game session for you? And if your current game is my cool game, they're going to say, oh, you are in a game on a different computer. Here you go. Go there, bring your token, and everything works as before, except now it will disconnect any currently connected user with your same username based on their connection, which we keep track of all the connections and associate them with any user. So that is session preemption. And that means we're only allowing a single connection per authenticated user across all devices. And you can get back into your game if you left your game on at home and you went to work and now you got to play at work or whatever the situation is. So that is the whole design as far as I remember it. It's been a while since I designed it, but hopefully that's coherent and helpful when designing your own distributed, scalable, multiple game servers architecture with reconnection and session preemption. And with that being said, this has been Mike Silverman. Hope you enjoyed, and I hope to see you in the next one. Take care. Bye bye.